So in this video, we're going to talk about something that can really make your life much easier when you're doing your integrals in your calculus course. So up till now, when you've done your integrals, you've had to use the fundamental theorem to explicitly write out what is the answer to the integral. So for example, you may have seen something like x squared dx from -3 to 3. Now, up till now, what you would have done is use the fundamental theorem to say that, well, this is 1/3 x cubed from -3 to 3, and then plug in all of the numbers after that. But we can use what we know about algebra and functions to simplify our lives quite a bit. So if you remember, back in the days of algebra, you talked about things called even functions and odd functions. So just to have a little bit of a review, an even function has the property such that f even of negative x is equal to f of x. And so a function that has this property is something like f of x equals x squared, because no matter what you plug in, f of negative x is negative x squared, which is x squared. So that's what we call an even function. Odd functions have the property such that f of negative x is equal to negative f of x. So functions that have this property are something like f of x is x cubed, because f of negative x would be negative x cubed, which is negative x cubed, which is, of course, negative f of x. So, as you can see, even functions are, as the name would imply, functions that have an even power. Now, there are other functions besides polynomials, but polynomials are the easiest to recognize. So, you may remember that along with these definitions come certain symmetries in the graphs. So, an even function might look something like this. It has symmetry about the y-axis. So if you reflect it, you get the same thing on both sides. An odd function, on the other hand, looks something like this, where if you go to a value x, it's up here, but if you go to the negative of that value, it's just the negative value of f of x. This has symmetry if you rotate it 180 degrees. So what we can do in integrals is exploit this symmetry. Because if we were to go and ask ourselves, what is the integral of an even or odd function, say, integral from negative b to b of f even of x dx, remember that the integral is interpreted as the area under a curve. So we're asking, what is the area, say, from here and here? So we want to find these areas. But because an even function has this perfect symmetry, what we can say is that this area is completely equal to that area. So the total area is equal to 2 times the area on either side. So we can simplify the integral of an even function as integral from negative b to b, so the bounds have to be the same, just negative of each other, of f even is really just 2 times the integral from 0 to b of f even dx. Let's do an example of this. Let's go back to our example of -2 to 2 of x squared dx. So we can write this as 2 integral 0 to 2 x squared dx. And then we just use the fundamental theorem to finish it off. So we get 2 times 1/3 x cubed, evaluated from 0 to 2. So we get 2/3 times 2 cubed, which is 16 So let's simplify our life a little bit. Let's look at what happens when we want to integrate an odd function. So if we have an odd function from negative b to b, what we're asking is find the area under a curve like that. So if we look at this, if we go from b to minus b, we're asking what is this area? Well, remember, the area above the x-axis has a positive value. Area below has a negative value. And just like before, this area is equal to this area, but this area is an opposite sign. So, our total area is 0, because it's a minus a. So, if we integrate from negative b to b over an odd function, we get 0. And so let's see an example of this, see if it's true. Let's integrate negative 1 to 1 x cubed dx. Well, that's 1/4 x to the 4 from negative 1 to 1. So that's 1/4. We get 1 to the 4th minus 1 to the 4th. Well, that's 1/4. 1 minus 1, which is 0. So we see that these symmetries can really simplify our lives when we go to do these problems. Okay, so what we want to do now is use these symmetry properties to really help us solve a hard integral. So let's look at this. Let's say the integral from minus pi to pi of x squared sine of x dx. Okay, so in order to do this, we need to know the rules for multiplying even and odd functions. So there's a couple rules we can have. We can have even times even, and that'll give us an even function. We can have odd times odd, and that'll give us an odd function. Or odd times odd gives us even. An odd times an even gives us an odd function. Okay. So what we have is an even function times an odd function. So the result is an odd function. So we're integrating from negative b to b of an odd function, so we can immediately say this is 0. We don't have to do any work, we don't have to do any integration, we don't have to use the fundamental theorems or anything. We can just say, by symmetry, this integral is 0. So this is really useful when you get very tricky integrals, but you notice a symmetry in the integrand. So if you see this symmetry, you can just stop what you're doing and just go ahead and write down the answer. So this can be really useful on a test or if you're just trying to get work